Hi everyone, it's Math with AUB. In connection with the preparation of ECAT+NET+, Punjab Board+AgaKhanBoard+SindhBoard, I have selected some questions for first year, and from past papers. Our question number 1 goes as, if 4 raised x is equal to 1 upon 2, then what is value of x? Such equations are known as exponential. Exponent means power. Our variable lies in the power. That's why it is known as exponential equation. Okay, cool. 4 can be written as 2 square times x. 1 over 2 can be written as 2 raised minus 1. Look at this. 4, 2 square times x. 1 over 2 can be written as 2 power minus. Is bases are equal, therefore powers are equal. 2x is equal to minus 1. Solve for x is equal to minus 1 over 2. X is equal to minus 1 over 2. So our option number B is the right option in that case. Okay, cool. Question number 2. What is the degree of a constant polynomial? Constant means anything, A, B, C, or any number, real number. It can be written as A times x, A times x raised 0. So degree of a constant polynomial is always 0. Degree of a constant polynomial is always 0. Constant polynomial means constant, no variable. No variable can be accommodated for polynomial as A times x naught or any real number times x raised 0. So it is constant polynomial. So degree of constant polynomial, power of constant polynomial is 0. I have done this thing for you. Question number 3, a good question. To me, it's a good one. It's really good one. It reads as, partial fraction for x square plus 1 over x plus 1 minus 1. Partial fraction for x square plus 1 upon x plus 1 x minus 1. Student in haste write a over x plus 1 plus b over x minus 1. They are linear and different. No, hang on. Their degree is same. Whenever the degree of numerator and denominator are same, apply synthetic division first, then partial fraction. If degree of both numerator and denominator are equal, if degree of numerator is greater than 0, then denominator synthetic division. If degree of numerator and denominator are equal, apply synthetic division. Or degree of numerator is greater than denominator, still apply synthetic division. Then you are in a position to apply partial fraction. Okay, cool. Let me solve this for you. A good question to me. X square plus 1, x plus 1, x minus 1, x square plus 1, x plus 1, x minus 1 can be written as x square minus 1. Okay, apply synthetic division but in a simple fashion. X square minus 1 plus 2, minus 1 plus 2 means I will get 1 same. Divided the denominator separate, x square minus 1, x square minus 1 cancelled out. So I have 1 over 2 upon, factorize this one, x minus 1, x plus 1. So the required partial fractions are 1 plus a over first bracket, b over second bracket. Brackets are interchangeable. X plus 1 here, x minus 1, it's okay. But don't forget, look at this. Degree of numerator and denominator are equal. First apply synthetic division, then partial fraction. If degrees of numerator and denominator are equal, apply synthetic division. If degree of numerator is greater than denominator, then still apply synthetic division. Then look for partial fraction if possible. Okay, cool. Question number next. Arithmetic mean between 1 over a and 1 over b. Arithmetic mean of 1 over a and 1 over b. 1 over a, 1 over b. 1 over a, 1 over b. Arithmetic mean. Am is given by sum divided by 2. 1 over a plus 1 over b divided by 2. Or it can be written as LCM b plus a over ab times 2, or a plus b divided by 2ab. Arithmetic mean between 1 over a and 1 over b is simple. Formula for this one is x1 plus x2 divided by 2, like average of two numbers, mean of two numbers. Arithmetic mean 1 over a, 1 over b means their sum divided by 2. Their sum divided by 2. Cool. Moving to next question. Oh, a good one. Mostly these three types of sum are present. It is sum, well, let me write 1 square plus 2 square plus 3 square dash 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 is equal to how much? Sum of squares of first n natural number. Sum of squares of first n natural number. Sum of squares of first n natural numbers is given by n times n plus 1 times 2n plus 1 over 6. That is sum of squares of first n natural numbers. Sum of first natural number is given by 1 plus 2 plus 3 up to n is given by n times n plus 1 over 2. And the sum of cubes of first n natural number is given by 1 cube, 2 cube, 3 cube dash 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 n cube. It is given by n times n plus 1 over 2. They are both identical up till here. Just square the cube. Square this one. Square this, n times n plus 1 over 2. They are almost identical except square. That is the sum of squares of first n natural numbers n times n plus 1 to n plus 1 over 6. Sum of first n natural numbers 1 plus 2 plus 3 plus up to n is n plus n plus 1 over 2. And the sum of cube of first n natural number is given by n times n plus 1 over 2 overall is square. So option in that case, it was this one. And what about this? This a plus b over 2ab. In that case, C is the right option. Now we are asked to factorize a square plus b square. The factors of a square plus b square are not possible in real numbers, but in complex number they are possible. It can be written as a square b square times iota square. Value of iota square is minus 1, value of iota square is minus 1, minus plus 1, we have same quantity. Now it is difference of two square situation, we can easily manage a plus b iota times a minus b iota. So right option in that case is option number C. Option number C. Okay, cool. Moving to these remaining 4 MCQs, let's see and find out. Yes, the proposition P, if P then Q, P implies Q and Q implies P means it is bijection. P implies Q, P implies Q, bijection. It's a bijection. Bijection, or it is known as necessary as well as sufficient condition. Necessary and sufficient condition. If P then Q is true, then Q and Q then P is also true. If Q then P is also possible, true, then it is known as bijection, or necessary and sufficient condition, or more accurate and mathematically converse is true in that case. Converse is true in that case. Converse is true in that case. Okay, cool. Others two, it is a good question. Inverse of any non-similar matrix is given by adjoint A divided by mod A. Mod A. It is identity. Just shuffle mod A here, determinant of A here. Mod A times A inverse is equal to adjoint A. If such type of MCQ is present, then it is going to create problem for you. It's inverse routine question. A inverse is equal to adjoint A. Overall A is given by this one. Just shift determinant times A inverse is equal to adjoint A. A good identity then. In the same fashion, for symmetric matrices, A transpose is equal to A. If this one can be written as A minus A times A minus A transpose is equal to 0, then it is a good MCQ as well. This one is routine, this one is good one. Okay, cool. If A and B are non-similar matrices, then inverse opens in that fashion. B inverse, A inverse, B inverse, A inverse. Let me explain to you this as well. If the inverse of A and B, C are possible, then A, B, C whole inverse can be simplified as C inverse, B inverse, A inverse. Same is true for the transpose of matrices. A, B, C whole transpose is equal to C transpose as well as B transpose, A transpose. Mostly students get confused when K is a scalar, any real number, where K is a scalar, any real number. Real number has nothing to do with transpose. Real number has nothing to do with transpose. Then it is given by K times B transpose times A, where K is any K is any scalar. Scalar means real number. A scalar means real number. The final question for today is this one. Really very easy. 1 minus tan square. Tan square can be written as sin square alpha over cos square alpha. Similarly, 1 plus tan square is given by sin square alpha, cos square alpha. Whenever you are going to negotiate such type of question in trigonometry, try to convert complete thing in sine and cos, in sine and cos, in sine and cos. It works wonder for you. Now I have written 1 minus instead of sine instead of tan, sine over cos. Having square tan square, then sine square over cos square alpha. Similarly, in the denominator 1 plus sin square alpha over cos square alpha. Taking LCM, we have cos square alpha. It's equal to cos square alpha minus sin square alpha. Okay, cool. Here, denominator is again cos square alpha. Here we have cos square alpha plus sin square alpha. Cancelled out. Cos square alpha minus sin square alpha. And in the denominator we have cos square alpha plus sin square alpha. It is equal to 1, and cos square minus sin square alpha is equal to cos times cos 2 alpha over 1. Sorry, cos 2 alpha over 1 means cos 2 alpha is the eventual answer. What is the bonus tip from my side to you is that whenever the question of trigonometry is present, try to convert this one into sine and cos. Sine and cos. Simple trick works wonder for you. It's my tiny effort to you guys to help you in your exams. It's all by itself. Next.